Okay, welcome back to week 2 discussion on ions and valence electrons and orbitals, etc. Okay, so we just learned about ions. What are those two types, cations and anions? Okay, now everything we have learned so far, it hasn't changed. We just have to make some accommodations. Okay, so how do we write a electronic configuration for sodium plus 1? All right, first, for novices or people that can't make that huge leap, what I want you to do is first write the electronic configuration for sodium, which is 11. So it's got 11 protons and 11 electrons, right? So 1s2, 2s2, 2p6 and 3s1. This is the undisturbed ground state of sodium. Okay, now I did spoke to all of you. Sodium is in 1a. That means it can only lose 1 electrons, and it's being a metal, it can only lose electrons, and how many can it lose can be governed by the Roman numeral, which is 1. Okay, and I also told you, where do these electrons get lost or gained? It's from the valence orbital. Valence orbital loses its valence electrons, okay, to make an ion. You cannot just remove anywhere as you wish. I have seen that happen, and despite saying it several times, it still continues to happen. So there's a problem with the way I say it. Maybe not. We'll see. So valence orbital on the sodium is right here, which is this 3s1, right? That means when you make, there's a difference between these two are not the same, okay? They're different. Sodium plus 1 and sodium in its ground state are two different things. Sodium ground state is a whole element, whereas a sodium is plus 1 is an ion. So to make sodium plus 1 and write its electronic configuration, all you got to do is, I'm going to grab my red so you can see what I did and the sharp contrast between the two. So all you got to do is remove this 1 electron. In other words, just don't write it when you write it back. So sodium plus 1 would be 1s2, 2s2, 2p6. You see? And that means now we only have a total of 10 electrons because we've lost 1. Does that make sense? All right, let's do one more, okay? Let's do, say, calcium, okay? Let's go get the periodic table for calcium, which is 20 is the atomic number. So 20. That means and it's in 2a. That means calcium is a metal, can only lose 2 electrons. That means calcium can only make Ca2+. It cannot make 3+, 4+, 5+, etc. So again, for people that are still getting used to the idea of configuration, go ahead and write the regular configuration, which means it's got 20 protons and 20 electrons, and I've emphasized we focus on the electrons, and you use your electronic configuration notation 3s. Okay, so it's just 2, 2, 6, 2, 6, that is 20, and 4s2. If you also noticed, 4s is by itself, so that is the valence orbital, and it also makes sense that it's 2a. That means you can only lose 2+. So to make Ca2+ configuration, all you've got to do is just get rid of the 2 from the picture. So Ca2+ would be 1s2, 2s2, 2p6, 3s2, 3p6, right? All we have done is that calcium has lost 2 electrons, so we no longer need 20, we only have 18 now. I believe so, yeah, 18 electrons. All right, so this is how you write electronic configurations for ions. Okay, all right, so let's do one more. for a non-metal. I believe I have done it already, but it's never too late to address it. So nitrogen, okay, nitrogen is 7, and I believe it's in group 5A. Okay, it's a non-metal, right? Nitrogen is a non-metal. That means it can gain, to go from 5 to the magic number of 8, it needs 3 electrons, right? So that means nitrogen can make N3 minus. Remember, when it gains in chemistry, it's minus. When it loses, it's positive, right? So let's go ahead and write the regular configuration of nitrogen, which means it's got 7 protons and 7 electrons. So the regular configuration would be 1s2, 2s2, 2p3, right? But remember, don't forget the discussion from earlier. So the valence orbitals here is this 2, because the last is 2p, but then it's got a 2s, right? So together they make the valence orbital, which accounts for the 5a. But now we want to do N3 minus, means we're going to add 3 more electrons. Well, even though we have 2 valence orbitals, the outermost of the 2 is the 2p. So whatever electrons you add should go there first. You cannot split it between them, or you cannot add it to the 2s. It can only be added to the outermost of the 2. So it's 1s2, 2s2, 2p6. This is where I've added the 3 additional electrons. Does that make sense? Okay, so this is how you do electronic configuration for ions. All right, I'm going to stop the video here, and the next couple of videos would focus on the periodic trends. They are pretty simple, and I do want to share my PowerPoints in the context of this, and then we'll probably be able to wrap up week 2. All right, stay tuned. I'll be back with a fresh screen and a fresh concept.